This afternoon, I have the pleasure of introducing Mark Zuckerberg, which is one of our guest speakers this semester, to come and talk a little bit about computer science in the real world. As most of you probably know, as you guys are all do this much more than I do, founder of Facebook.com, which is a social networking program, whatever you want to call it. Used at over 2,000 schools across the nation and possibly the world. Is it the world too, or just the nation? Okay. So good influence for doing some things in computer science. He's going to tell us some of the background of it and what's been important and so forth. So please join me in welcoming.
Yo. All right, cool. This is the first time I ever have had to hold one of these things, so I'm just going to attach it really quickly. One second. Can you hear? Is this good? Is this amplified at all? All right, sweet. So, this is like one of the first times I've been to a lecture at Harvard. So I guess like what's probably going to be most useful for you guys if I just take you through some of the courses that I took at Harvard, where I actually did go to lecture sometimes. I was joking, and sort of like how different decisions that I had to make when I was moving along with Facebook got impacted by different stuff that I was learning in the classes that I was taking. And if all goes according to plan, then maybe some of you guys will come out of this thinking that taking CS or engineering stuff at Harvard is actually sort of useful. So that's the game plan. I think that this is slotted for 2 hours. There's no way I'm going to speak for 2 hours. I'll probably speak for like 20 minutes or 15 minutes, and then I'll just let you guys ask questions, because I'm sure you guys have more interesting stuff to ask me than I can come up with to talk about myself. So, okay. So I guess I'll just kind of get started. When I was here, I started off taking 121. I never actually took 50, so I'm probably, you should have gotten the other guy who was doing Facebook, Dustin Moskovitz, who is my roommate. When we got started, the site was written in PHP, which isn't something that you learn in one of these classes, but fortunately, if you have a good background in C, the syntax is very similar, and you can pick it up in like a day or two. So I started writing the site and launched it at Harvard in February 2004, so I guess almost 2 years ago now. And within a couple of weeks, a few thousand people had signed up, and we started getting some emails from people at other colleges asking for us to launch it at their schools. And I was taking 161 at the time, so I don't know if you guys know like the reputation of that course, but it was kind of heavy. It was a really fun course, but it didn't leave me with much time to do anything else with Facebook. So my roommate Dustin, who I guess had just finished CS50, was like, hey, I want to help out. I want to do the expansion and help you figure out how to do the stuff. So I was like, that's pretty cool, dude, but you don't really know any PHP or anything like that. So that weekend he went home, bought the book Perl for Dummies, came back and was like, all right, I'm ready to go. I was like, dude, the site's written in PHP, not Perl, but that's cool. So he picked up PHP over like a few days, because I promised that if you have a good background in C, like PHP is a very simple thing to pick up. And he just kind of went to work. So the first big decision that we really had to make was in how to kind of expand the architecture to go from the single school type setup that we had when it was just at Harvard to something that supported multiple schools. So this was a decision that kind of had to be made on a bunch of levels, both like in the product and how we wanted privacy to work. But I think that one really important decision that's helped us scale pretty well is how we decided to distribute the data. So I don't know how much of like kind of complexity stuff and like big O notation you guys do in this class. Okay. So one of the most complicated computations that we do on the site is the computation to tell how you're connected to people, right? Because if you can imagine that's stored as sort of a series of I guess undirected, it's not weighted, so undirected, unweighted pairs of ID numbers of people in the database. Then if you want to figure out who's friends with someone, you have to look at all their friends, right? So that's maybe like 100 or 200 people. But then if you want to figure out like who's a friend of a friend or what the closest connection is there, then you kind of have to look at the 100 or 200 friends of each of those friends. So it becomes like at each level, there's another factor of n multiplied in, where n is the number of friends that the person that each of your friends has. So you can see that this kind of becomes exponentially difficult to solve for the shortest path between people. So I mean, if you're just looking for a friend of a friend, that's n squared. If you're looking for a friend of a friend of a friend, that's n cubed. And I mean, that's something that traditionally was pretty difficult for a lot of the predecessor sites to Facebook. So, and for example, Friendster had large problems with this because they were trying to compute paths 6 degrees out or like 7 degrees out. And I mean, that's something that when you're doing like n7th, like that just is really, I guess, very hard, and took down their site for a while. So I mean, one of the things that we kind of had in mind when we were figuring out how to do this was how do you distribute the database in such a way that this computation becomes manageable. So what we decided was that everyone on the site does most of their activity at the school that they're kind of based at. So if you're at Harvard, then like most of the people who you're going to be seeing or transacting with on the site are going to be at Harvard. It's actually probably like 90% of the stuff that you do on the site. So we decided to split up the databases and create one instance of a MySQL database for each school on the network. And in doing that, I mean, if you notice, the paths that we compute are only within the school. So instead of, say, like now we're at 6 million users, and instead of having to do n cubed over some portion of 6 million, it's just n cubed over 10,000, which is a much more manageable, I guess, type of computation. So that was sort of the first like big architectural decision that we had to make that contributed to us not dying a few months later. And I don't know, it was probably like a pretty important one. So I mean, when we first set up the site, we had just one computer that we were running. It wasn't in our dorm room, we were renting it. I kind of learned my lesson for trying to run a computer, run a site out of my dorm room a few months earlier, and Harvard almost tried to kick me out. So so I ended up renting a server off-site this time, and I guess like running originally the database and the web server, so Apache is what we were using in this instance, to serve the pages from the same machine. And because we distributed the databases in the way that we did, we were able to, as time went on, just add more machines linearly and sort of just grow the site without having any kind of exponential expansion on the amount of machinery that we had. But after we hit, say, about like 30 or 50 schools, we started realizing that we could start getting more performance out of MySQL or Apache, and that like some of the way that stuff was set up just like wasn't as optimal as it could be. So I mean, for example, when you have MySQL machines and Apache machines on the same, or like MySQL and Apache running on the same server, then if something happens to that server, then not only does the database for that school or the schools on that server just stop kind of responding in a way that is like, that will get you anything useful, but you can't even load any web pages, so you get page not found. And that kind of sucks. But another issue is that the variance and the use from school to school is also not going to be perfect. So I mean, some schools are always going to be kind of have heavier use. I mean, we have schools now like Penn State that have 50,000 users, and then the majority of the schools I think still have less than 2,000 users. Just because there's a lot of small schools and a lot of schools that don't have complete ubiquity. So I mean, in trying to deal with this issue and like kind of make it so that you could deal with the fact that Penn State had 50,000 people and just a ton of users all the time, and then you have some schools that don't. What we decided to do is separate out some of the web servers from the database servers and make it so that you could, so that we just had a pool of Apache web servers that we could load balance between and make it so that you can use those uniformly while just having the database layer be sort of consistent. So I don't know if this stuff is interesting to you guys at all, or I mean, if this is anything that that matters to what you guys are studying now. I mean, so if there's more stuff that you guys would rather know about in terms of the architecture, then I'll kind of leave that open to questions later. So I'm just that I don't spend a lot of time just talking about random applications that you guys might not ever care to use. But let me try to find some interesting examples. So, I mean, I guess one of the things that was pretty interesting was just sort of trying to, like, when we got to a point in terms of traffic where we started maxing out the performance of some of these open source applications that are generally pretty performant. So for example, MySQL is a really good open source database. Right? And I don't know if any of you guys sort of in your own time mess around and like make anything with MySQL or have used it in any way. But like, I mean, it's pretty easy to use, and it's also like decently quick. You know, indices work pretty well. It's not as fully featured as something like Oracle, but it's pretty good. And I mean, we got to a point where I think around when we started doing like maybe 100 million page views a day, that that we started running into some bottlenecks on that. So like, so for example, a typical query on MySQL might take like 2 to 4 milliseconds. And I mean, that's not that much, but like when you're doing 100 billion of page views a day and each page view might have like 30 to 50 queries, I mean, especially if you're doing something like a profile view that just kind of queries all kinds of different information, then that kind of starts to suck. So we started to develop a caching sort of layer that kind of allowed quicker access to some of the information. And originally we were using another open source application, Memcache, which I don't know if any of you guys have any experience with that. But like, it was pretty quick. It got access times down to like, I guess like 0.3 to 0.5 milliseconds, which is pretty good. But it also like has a bunch of sort of distribution issues. And I mean, it's supposed to be like a distributed hash table sort of application where it's like, you can just attach like any number of Memcache boxes in a cluster and be able to just like hook it up and have it go. But we sort of ran into a lot of issues there where like different Memcache boxes would go down and there was no redundancy on the information. So like when a Memcache box went down and you had a cache miss, then all of a sudden like you had a lot more traffic going to like a specific set of databases, and that would suck. So so as time went on, we even kind of like outgrew Memcache and sort of the indices on MySQL. And I mean, we still use that stuff, but we had to build on top